Joe, we are on section 201 of water testing now. This is episode 45 of the Rule Your Pool podcast. Joe, what are we talking about in this one?
We're really going to be talking about advanced water testing. We're going to talk about the problems that you might face and making sure that you get the test right. There's a lot to it.
Yeah, well, we're going to simplify it because that's what we do here. I'm your host, Eric Knight. This is Joe Swayze, our sales manager, and he's got over 20 years of experience specifically in water testing. So we're very grateful to have him here. Let's just cut right into it. This shouldn't be too long of an episode, I don't think, right?
No, I don't think it'll take too long. We're going to hit the most frequently asked questions, we'll say, and knock it out pretty quick.
Sounds good. Episode 45. We're going. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go.
So with water testing, as with a lot of things in pool chemistry, it's pretty easy to get it wrong. And we, because of the experience that I have at Hawk and the experience that we have doing troubleshooting testing, et cetera, at all the pools that we've seen, we kind of know that there's a lot of things that can go wrong. And it's really, really simple to do it right if you just know what those things are and avoid them. So we're going to talk about a few of those things. And let's start with probably the most simple of all of them. And that is just following directions. We talked about this a little bit in the last episode, but we're going to go into a little bit more detail here now. And the directions are really important. You know, when you read the typical, snapshot directions that are on the container, that's great. Definitely helps to make sure that you're getting the test result that you want to get. But sometimes the helpful tips, the things to get the most accurate, most precise result are buried a little bit beyond that. Maybe it's on the website, maybe it's in the additional packaging material, et cetera. So here are a few of those things. If you're using a liquid kit, the bottle angle is important. You want to hold that at a 90-degree angle down so that the bottle tip is down onto the solution and you get an even drop size.
Perfectly
You also
vertical.
want to perfectly vertical.
Mhm.
You want to also make sure that the tips are clean. So you wipe those with a clean cloth every once in a while, or a something that doesn't have an oil or lotion on it. Paper towel, something like that. And again, no oils, no lotions. You don't want to leave any of that on there. That can affect the drop size. The drop size is important, and the angle that you're using it is important. Storage is critically important to testing products, whether we're talking about the sensors that need to be stored wet or need to be stored in some calibration solution. Figure out how those need to be stored. Your liquid and test kit reagents are all subject to heat and humidity. All of them, whether it's a reagent kit, whether it's a test strip, if it is reagent based at all, heat and humidity are the enemy of those great test results. So store it in a cool place, keep it out of the sunlight as much as possible. Don't put it on the truck dashboard. Don't throw it in the back. Don't certainly throw it in the container with your chlorine and things that are going to oxidize those. Take good care of it and it will take good care of you. Caps. Really important that you keep the caps on in between uses. I've seen a lot of places where I go and you get into a water room and the caps are left off because it's convenient. You spend less time doing the test because the caps are already off. Well, guess what? You're exposing that to oxidation, to humidity, to things that will change those test results. So Keep the caps on, keep them tightly sealed.
That's one I wouldn't have thought of because I've been in a lot of pump rooms, and you're right. I see a lot of reagents that just have the lids off because they use them so many times, 2-3 times a day in a commercial pool. I never even thought about the cap being off as being a problem. But now that you say it, I have a lot of people to call after this.
It's definitely something to keep an eye on. And, it'll change the test result. Now, it's not going to change it overnight, right? Like, we're not talking about 24 hours or 48 hours. We're talking about probably over the course of a couple of weeks, and it will affect the results. So if you leave it in the truck bed and it's 120 degrees in there, and 3 or 4 weeks later, you start seeing results that are inconsistent, that's because it changed.
Yeah.
It doesn't take a long time to affect the shelf life of a product.
Well, I guess that segues into expiration dates, because it sounds like you could have an expiration date. Number one, obviously you don't want that, but you could be accelerating the expiration of that reagent before its expiration date, is what it sounds like.
Absolutely. Absolutely. Expiration dates mean nothing if you're not storing it properly. All right. It's just, they mean nothing. But all of the products that we test have a finite shelf life. Everything does. Some of them more than others, but know what the shelf life is of the test that you're doing. And not everybody prints the shelf life right on the container, on the packaging, somewhere in there. You might have to dig a little bit for it. Sometimes you have to put it into a calculator or something. I know it's difficult, but at least know what the shelf life is. So if you're getting fresh reagents, about how long can I expect those to last? If the expiration date is printed on the bottle, look at it. Did I get a fresh set of reagents? Sometimes things get caught in distribution and they find them months, weeks later, and they pull them out and go, oh, hey, we got to sell these now. Well, yeah, you probably don't want something that's a month away from the expiration date,
Yeah.
because who knows how they've been stored, right? You
Yeah.
want something that's as fresh as possible. And there are ways to make sure you're doing that. And number one among that is to make sure that you know what the expiration date is when you get it. If you don't know it, find out.
Right on. What's next?
So let's talk a little bit about what can go wrong with the tests, right? And we call them testing interferences. The interferences, the things that can make your test inaccurate, that you have no control over or a little control over. And one of the big ones is sanitizer itself. So let's talk about the chlorine test or bromine test, or, sanitizer test in general. When you're testing sanitizer, there are a couple of things to look out for. And it's really simple if you have experience doing this and you see it. And the first time you see this problem, you go, wow, I see that. And then down the road, you know what you're looking for. One of those is bleaching. If you have a reagent that's bleaching out, and we see it all the time because the sanitizer level is really high, and you get this flash of color, right? So if you're doing a liquid test, you drop it in and there's a flash of color, you get color there, it's reacting to something. It's probably reacting to the chlorine that's so high that it's bleaching back. So when you add the drops of color and you get that initial swirl, or you even see it where the color's there for a second, but then it disappears, your level is probably very high. So the best thing that you can do in that scenario is to dilute it down with some water that has no chlorine in it. If you have distilled water on hand, great. Not many people do. Use a little bit of tap water. Very unlikely that there's much chlorine in there, if any. And so it won't impact that test. You can dilute it down, say 2-to-1 or 3-to-1, and then multiply it back out and see what your level is. So if you do a 2-to-1 dilution, for example, you've got 50% of the pool water, 50% of tap water, and you get a reading that's, let's say, 10 parts per million, you've got at least 20 parts per million in there.
Well, I want to reiterate what Joe's talking about here is a free chlorine test kit,
Yep.
or sorry, not test kit, a free chlorine test, because you can't do this with pH or alkalinity or calcium, because then you're going to be blending a completely different source of water, and that's going to distort your views. But if you're just measuring chlorine in this sense, or cyanuric acid could also be diluted that way, something that would not be in tap water. Now,
Yep.
some tap water does have chlorine, Joe.
A little
Like
bit,
mine,
yeah.
mine has 1 part per million here in Charlotte where I live. But what about neutralizing? Doesn't the reagent test kit have some thiosulfate in there that could neutralize chlorine?
Yeah, some of the test kits do have the thiosulfate in there, so you can neutralize the high level, and then you test it again and see where it's at. So absolutely, again, follow the directions on that, because they are a little bit different for each one, but you can neutralize it as well. If you're using a test strip or you're using a colorimeter, same kind of thing. Those colors will often appear and then vanish, kind of bleach out. Maybe they leave some remnant of that color behind. What we call window framing on the test strip, where you get a little bit of color around the edges, but nothing in the middle, probably again, bleaching it out. And the one thing that people often overlook, I think bleaching tends to be something that people recognize, but what you might not recognize is the impact that it has on other tests. When you have a high sanitizer level, your pH and your alkalinity might also be affected, to where you're not getting an accurate result. So what you need to do is wait till that chlorine level comes down to an acceptable level and retest your pH and alkalinity. Pretty common to see that. And what happens is your tests become colors that you're not used to seeing. So your alkalinity is blue or yellow. And it's, changing the coloration of those tests. Your pH might be a pink color, maybe even purple. And those are the regular indications that you're seeing something that's just not right, something that's not the way the test should be. Then you go and figure out why you're seeing that.
Right.
So that's probably the most common one, is that your chlorine or your sanitizer level is so high that it affects, number one, that test by either bleaching it or getting a color that doesn't look quite right. And it's affecting your pH alkalinity.
Yeah, I know it can affect the number of drops in the drop kit for calcium hardness, or at least that's what I've been told. So just putting in a drop of thiosulfate beforehand and then doing it, it actually makes it a lot easier to get an accurate reading. Because as far as I know, thiosulfate does not contribute at all to calcium hardness. I don't know why it would. So it's not going to distort that test. It's only going to make it more accurate by neutralizing some of the chlorine. So yeah, would you say that high sanitizer is the most common interference that you see in testing?
I would say it's probably the most common interference that we see in season.
In
There's another
season, okay.
interference. There's another interference that we see a lot, particularly in the springtime, because of the demand for chlorine, and that is the chloramines that form, the combined chlorine that forms, is oftentimes a interference for your free chlorine test. So let me give a little context to this one, because we see it again more in the springtime. And that is when you have, heavy organic loads from what was over the course of the winter built up in the pool, or, you're starting in the springtime and you've had a bunch of leaves and things that were there. You get a bunch of, pollen blown in, et cetera.
Tannins and
And
all sorts of
all
organic
of that
mess.
stuff, right? So those things, the chlorine has to react with those to get rid of them, and they form chloramines. So when we measure chlorine, we measure two forms of it: the free chlorine and the combined chlorine, and those together form the total chlorine. But what we see oftentimes, not just in the springtime, but more in the springtime, is that your combined chlorine level is high enough that it starts to react like free chlorine.
Mm-hmm.
And you can look at this a couple of different ways. It doesn't happen as much on the test strips as it does on the test kits. And that's just a type of the reagent that's used. But what you tend to see is that there's no color in that reagent. Like when you drop it in, if there's no swirl of free chlorine, if there's no color immediately, it's not free chlorine. Free chlorine reacts immediately. But if you put the drops in there and then you mix it and it sits for a second and all of a sudden that color starts to develop, that's probably combined chlorine that's reacting and looking like free chlorine. If you don't recognize that, you say, oh, I've got this free chlorine level, when in reality, you probably have zero free chlorine, and that's just the combined chlorine reacting.
I
So
wonder how much of an effect this has on commercial pools that are heavily loaded, because we've done 2 episodes on combined chlorine. You and I did them.
yeah,
Combined chlorine 101 and 201, very similar to water testing 101 and 201. We seem to have a theme here on the Rule Your Pool podcast. But combined chlorine obviously means nitrogen's in your water. So if you have dead leaves, decaying, pine needles, all this stuff, those things do contain nitrogen. It's not the organics, it's not the carbon that's causing combined chlorine, it's the nitrogen compounds that are. And what you're saying is basically doing a very similar thing to high sanitizer, but it's happening slower. And I guess that makes sense, because chloramines do have, like monochloramine and dichloramine, they do have some disinfection power. They're just way slower, like hundreds of times slower than free chlorine hypochlorous acid.
yeah, and if they're high enough, if they're several parts per million high, which is not all that uncommon, it can react with your free chlorine test, and it
Hmm.
does pretty regularly. So we see that a lot again in the springtime, because that's when you see a lot of those typical loads of those nitrogen containing compounds. But it can also happen in the middle of the season from
I know.
bather load, the things that people bring into the swimming pool, urine and all those things, right? So it is something that if you just know what to look out for, just know that when you are dropping the DPD solution in there, when you're testing the free chlorine, it should react immediately. Free chlorine reacts
Mm-hmm.
instantly. And if you're not seeing that instant reaction, it's probably not free chlorine.
So, Joe, do you have any other chemical interferences? Because I got an interference that isn't chemical, but it happens a lot. But I don't know if you have any other chemical ones besides chlorine and combined chlorine.
Yeah, so there's, people will often dose with a non-chlorine shock, like a monopersulfate
Mm-hmm.
or a potassium persulfate, or even in some cases they use like a peroxide shock. Those, if you test right after those go into the pool, you can get those reacting like a chlorine test as well. They can also, temporarily adjust your oxidizer level high enough that you get those discolorations of the other tests. So know that when you're dosing up, especially with those non-chlorine shocks, give it a little time, and then your test kit should be able to adjust for those interferences.
Right on, right on. The interference I was thinking about is cold water.
Yeah. Yeah.
If
Or,
you've
hot water.
Yeah, I
Right?
guess so. So if you're below, different test kit manufacturers say different things, 55 degrees. We're going to say 60 at Orenda just because it's a little more conservative. But if you have cold water, you need to warm up that sample before you test it.
Absolutely.
It takes a lot more drops to get a reaction because everything's slowed down. Now, you would record the actual temperature of the pool with a thermometer when you're using the Orenda app to calculate the LSI. So you actually do want to know, oh, it's actually 43 degrees. You want to log 43 degrees in the app, but you want to warm up that sample in a bottle that's sealed shut. And Joe's going to explain that in a moment, I'm sure. But you want to warm up that sample before you test it so that the reagents have a chance to react. Otherwise, it's too cold and it's too slow, and you might think you have very little alkalinity or very little calcium in there, and you might actually have plenty, but the water's just too slow and it distorted the readings.
Absolutely. And an easy way to do that is if you got a small enough bottle, just tuck it close to your body. Put it in your shirt pocket, put it in your pants pocket. It'll warm up pretty quickly. Take it into the truck and leave the heater on in there. It doesn't take long to get it up there, and that 60-degree mark seems to be that kind of magic point. Some people do say 55, but I'm with Eric here. I think if you get to 60, you're safe. And just then, do the test like you would normally do it. So you're going to get your free chlorine, your pH, alkalinity, all those things reacting normally then. And the other side of that is when it's really hot. So, tests are designed to work in spot temperatures. So where it's, 102, 104 degrees. So you're probably not going to get any inconsistencies there. But if it's anything above that, and if you're using it for something else, other applications where your water temperature is higher than that, just know that you probably want to let that cool down into the normal spa and pool temperature ranges before you test those. So just be aware.
Now, I've taken a test. It was with a reagent test kit, and I was doing calcium hardness, and I'm doing the drops, and I do the 20 drops at first, and then I add the blue liquid, and I start titrating it, and I get these little pink or little purple floaties all throughout that water. And, the water is supposed to turn blue, but instead it seems like it's just turning these floaties darker and darker, and I'm not getting a reading nearly as clearly. What's that all about?
So
I think that what that's all about, and the experience that I have with that is typically when the magnesium is pretty high in the pool. So the majority of pools, calcium is by far the contributing factor to hardness. But there are some pools where your magnesium level also contributes to hardness, and it's can be a pretty significant amount. And in those cases, you might see that precipitate out and the coloration looks a little bit different. But keep going with the titration, because what you're ultimately looking for is that color change, that endpoint color change. It might also be a temperature factor like we just talked about. But what you're really looking for is that color change, and you still should be able to get it even if you're seeing that precipitate.
Okay, cool. I know we get that question quite a bit. I see a lot of texts that come in that are a picture of the purple floaties, and like, yeah, you've got some other stuff going on. I guess that's total hardness, not just calcium hardness. So if you're trying to titrate out or neutralize the magnesium to get to calcium, that makes perfect sense. So what else you got here, Joe?
So one of the other things that we saw a lot that just is a problem in itself is taking a sample somewhere, whether you're the service professional and you're taking a sample and you're going to take it back to the lab to test later, or you're the consumer and you're taking it to a pool store, whatever the scenario is. If you're taking a sample, the two big things are: one, you want to make sure that you get a good sample, and two, you want to make sure that you take it right to the source where it's being tested. And I'll give you reasons for both of those. Number one, for getting a good sample, you want a clean container. Can't say that enough. Make sure that it's clean. Otherwise, it's going to affect the water chemistry. All right. So just use a brand new water bottle or a plastic bottle that's been contained well. If you're using a glass bottle, make sure that you've washed it thoroughly, rinsed that soap then out thoroughly so that you're getting a good, clean sample. All right. The lid is also important. Don't neglect washing the lid. So keep it all clean. Second, you want to make sure that you fill the sample all the way up. So take that water bottle, submerge it all the way down into the water, say elbow deep, or at least, wrist deep if that water's really cold, and shake it up good so that all the air bubbles get out of that. Then pull it out and cap it tightly. All right. So you want to make sure that you get all the air out of that bottle, because air can contribute to oxidation, especially if you've got the agitation of that bottle as you're taking it to the store or you're taking it to where it's going to be tested. You have that oxidation taking place, and that will change the chemistry. The pH will go up, the chlorine might go down. You might see some other changes. So get a good sample, fill the bottle all the way up. And then the second thing is take it right there. Water changes, as quickly as 30 minutes from the source that you've taken it. So we see this all the time, that you take that good water sample and you do everything right, but you throw it in the car, then you go pick up the kid from school, you get some groceries, and then you take it to the pool store 3 hours later. That's not a good water sample. The water is going to have changed. The temperature is going to have changed. You're going to see things, because that volume of water is so small compared to the volume of the pool that you drew it from. You're going to see those changes happen much more quickly in that small water sample, in particular because of the agitation that you get as you travel, and the temperature changes often as you travel, and you won't be getting a representative sample then. So
That's
your best course
fascinating.
of action is
You have a
I didn't
question
mean to
about
interrupt.
that, or?
No, I didn't mean to interrupt. There's just a little bit of a delay on here, so I apologize for jumping in. I thought you were done, but I was saying that's fascinating because it makes perfect sense. Your CO2 is going to leave Henry's law until it equalizes with that little pocket of air. So taking all the air out of the bottle completely negates that, and the pH shouldn't go up. If you have a pocket of air in the bottle, the pH can go up and will, especially if it's shaking around and turbulent. So all that is good information. Even I didn't know that. I never thought take all the air out of the bottle, but it's making perfect sense.
Yeah. And then, get it there within 30 minutes. If you get it within 30 minutes, you feel pretty safe about it. It might be stable longer, but the faster you get it there, the better.
So why are we trying to get the sample from under the surface? You said at least wrist deep if it's cold, or elbow deep is the desired. Why are we grabbing from there and not just a splash of water from the top?
Another great question. And this is something that, a lot of the test kit manufacturers will tell you to go down, elbow deep when you're getting a sample. And that is because there's a thin layer of water that's actually changing compared to the relative large volume of the pool that's below it. And that's where you have that oxidation taking place. It's where you have the off gassing taking place. And it's a pretty thin layer. It's really like fingernail thin, but you don't want to siphon that layer into your test result when you're getting a test. And it's the reason why test strip manufacturers tell you to go down to a certain level, like wrist deep or, fingertip depth, because you want to make sure you're going down below that water level. If the water level's here, you're going down below that level that's changing, and you don't want that to impact the sample. So when you're getting a water sample, it's the same way. You want to go down deep enough that you're not siphoning anything from the surface. That's basically it. You
What
just
about
want to make sure
oils?
you're going down below the surface. Oils as well, because you get a lot of that surface oil, surfactant type stuff that can be on the surface. You want to make sure you go down below that. You're just trying to get a sample that's representative of the entire pool. And if you're not, going down below that level that can be changing, you're not getting a good representative sample.
Well, this is all great information. Is there anything what you want to add before I try to summarize? Or I'm
Yeah,
going to attempt to summarize.
Couple of other quick things that you want to make sure of. One is, lighting is important for your testing. You want to make sure that you're reading it in the best possible light, and they all will tell you, the test kits will tell you what that lighting is. But if you're, using a test kit, you want it to be indirect light. So the sun's at your back. You're not looking into the sun when you're testing. If it's a test strip, you kind of get a little bit of a shade to it. Maybe you use your body as shade, or you're getting it under a umbrella or tree or something in the yard. You want to make sure that you're not wearing sunglasses. I've been out to a lot of places where the service guy is wearing his sunglasses as he's doing the test. Guess what? You're impacting the test result. So take the sunglasses off, do the test right. Make sure that you're doing the test the way that you're supposed to. And the last thing that I'll say is, as far as the testing goes, there's a lot of things that can go wrong, but once you've done it a little bit and once you get comfortable with it, you recognize when you have a problem. Because if something doesn't look right on the test, something's probably not right, whether you've got an expired reagent or, look close at the reagent. Sometimes you can see like crystals that have formed in the bottom. Okay, that's bad. You don't want to see those, right? It's want to be clear. You want that reagent to look like it's always looked. If it's a yellow color, it's supposed to be yellow. If it's supposed to be clear, it's clear. Those are the types of things that you recognize when you've got a little bit of experience. So, pay attention to your test. It will tell you a lot by itself, just looking at it and doing the test result and, seeing, does something actually look different? Does something stand out that just is a little bit different than what I've been doing all along?
I like it. I'm going to attempt to summarize now. And yeah, good luck to me. Okay. Take care of your test kit. Watch out for expired reagents or neglected test kits that are sitting out in the sun, getting too hot or too cold. Take care of the reagents. Make sure you do not let them expire. Calibrate your electronics. Just make sure that your test kit is in good working shape. Now, when you're collecting your sample, get below the surface. If you're going to collect that sample, put it in a bottle to the brim, and it has to be a clean bottle. Make sure that you don't have contaminants already in that bottle, and take it right to the pool store so that you minimize interference. If you have too much sanitizer in your pool, you might have to neutralize some of that sanitizer or at least dilute your water with non-chlorinated water to get the proper chlorine level, or bromine or whatever it is you're testing. And if you see something wrong, just generally speaking, if you see something that just doesn't add up, like maybe the water is too cold and you're not thinking about temperature and you're putting in 60 drops for calcium, it's like, there's no way I have 600 because when I closed, I had 280. Yeah, well, your water's too cold. So when you collect your sample, warm it up. Make sure you're giving yourself the best possible opportunity to test accurately. Apart from that, I'm sure I missed some things, but those are the big ones that we experience, or certainly the big ones that I experience. And Joe, I appreciate you coming on here and talking about this, and I hope that this adds a lot of value to our listeners. Is there anything you want to add before we go?
No, just the summary sounded like a lot, but rest assured, testing is not that difficult. It's really just, making sure that when you do have a problem, you understand what that problem is. So that's why we're here.
Yep. Thank you, Joe. I'm your host, Eric. This is Joe, and we're so glad to have you back. Hopefully we can do more of these in the future, but we're traveling all over the place. So as always, if you like our podcast, please share it with those who you think might find value in what we're doing. And you can contact us if you have requests on what you want us to cover on here, or if you just have a question, info@orendatech.com, or you can reach us out. Did I just say reach us out? Reach out to us directly through the Orenda app. Thank you so much. This has been episode 45. We don't know what episode 46 is going to be, but it will be really good, because we're very good at this. Yeah. Clearly, this is what we spend most of our time on. Anyway, in all seriousness, we are so grateful to have you. It is awesome that we have the listening base that we have. 5 countries now, 6 countries, something like that. It's pretty amazing. So thank you for listening. Take care until next time.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.